system, and then anyhow we need space for turbos to give all that power. So you have to find quite quickly a petrol station. So would you ever buy a car like this? Nobody would, because you cannot manage. It's impossible to manage. You can manage maybe once, twice, but you will get bored the first time that you have to do all of this just to drive a car. Better to take a Ferrari that is not going at 400 kilometers per hour. It's not costing 2 million euro. And, well, you can stop after something like 3 hours of driving. So this is the same problem with intrusion detection system, with anomaly-based intrusion detection system. You cannot manage them. All the solutions that you can find today in, let's say, in the academy, for example, or, I mean, the best one, the one that you will say, wow, this is cool, and this is unmanageable. This is the big problem with intrusion detection system, with anomaly-based intrusion detection system. So, by the way, if you want to buy this car, it's this one, the Bugatti Veyron. They've sold 5 of them or 7. But it's nice, I mean, it's cool. Once in your life. Okay, so we have to overcome all these problems. Because otherwise, we are just providing another 100% detection rate at zero phase positive that is unmanageable, that you will get bored because you will need specialists to manage it. You will need to train your people, you will need to send them somewhere, they will spend a lot of time on writing the signatures, setting threshold, and so on. So we must make something usable, finally. So, of course, we have to overcome the same problem of the post data and the secure socket layer encrypt data. Then we have to overcome the problem of the source code, if you don't have it, if you are buying a third-party module to put on inside your web server. And, of course, we cannot use the logs. Then, of course, we want him to be anomaly-based because we want to catch the zero-day attack. But why, especially the anomaly detection system, are unmanageable? Because the first requirement that they want, that they need to really work properly is this. You must provide them a cleaning data set. And now I really want to ask to the people out there how they're going to make clean data set in their experiment. They're just saying, oh, I got clean data set somewhere. Good. I don't, and nobody can. So we must apply something to at least not really provide a clean data set, but something must be out, something must be popped out. And we want him also to be self-instructing. We will see later what this means. So, with all these properties, we can detect the zero-day attacks. We could generate signatures also for other systems that are not so smart as ours. So, this makes the deployment of this stupid intrusion detection system easier. So, are we just dreaming, or is it possible? Okay, this is not the silver bullet, but this is this. So, to satisfy the first two properties, we have to make the same deal that mod security did. So, we must be an Apache HTTPD module. Because only that way you overcome the problem of tampered logs, post data, SSL easily. Then our solution is anomaly based, so we can catch the zero-day attack. And how we're going to do that? Well, we are putting together different techniques combined at the same time to increase the detection, so to catch 100% attacks, and the accuracy, to lower down the false positive. But we have also to do something more to do just to achieve this goal. We have to pre-process what will be our training data set somehow to push out everything that, the much that as we can that is bad. How we will do this analysis to increase the detection and lower down the false positive? We will follow the same road, the same path that I showed you before. We will make a parameter content analysis. But different from before, we will be a little bit smarter and we say, well, if that is a number, I will treat it like a number. I don't care because it's a number. It's not going to change. Or if it's an email, or if it's a long text parameter, then we have to treat them differently from before. We cannot use always the same time, because the same model to analyze the content. And the last and the most interesting feature, I think, is the following. We can generate the signatures in an automatic way for mod security. That it's the widest web application firewall deployed in the world. So the guys will not lose the mind writing the signatures because somebody thought it was nice to add a new parameter in the web application. Okay. I guess the picture is not really the best. I think I have to visit the Guggenheim Museum once more, but this is what we thought could be a good solution in case, of course, you don't want to protect only Apache, because in that case we are just protecting, okay, we're protecting half of the world, but there is more. There is Microsoft, there is Sun, there is a lot. So if we put our model inside a proxy, and everybody, if any enterprise company today have a load balancing system for their web servers. So that means that we are just putting something somewhere that is already in place. We don't need to add new hardware. If we put our model here, then we can protect everybody without putting too much effort. Okay? It comes for free to protect Apache and IIS at the same time. Okay, so now we're going to talk about the engine. What is it really inside the stuff? So, first of all, as I said before, any anomaly-based intrusion detection system is going to go through a training phase because they need to learn what they have to protect. And this is the biggest point, because if you provide them a training data set that is containing attacks with some dirty noise inside, the system will learn it, the system will use it, and it will not detect it after. That means that you will lose the 100% detection rate. So, because nowadays we have botnets scanning 24 hours per day, automatic scanners, script caddies, they are doing everything, searching for well-known vulnerabilities, finding the worst configuration possible, and so on. We must find out a way to clean it. We have to avoid this noise somehow. Let's say that, of course, if this was a good detection technique, it would not be used to clean the dataset, but it would be used to detect real attacks. So, what this cleaning phase can do, it's not, I would not say so little, but it's not so big. And let's say that you can detect in this way, you can detect, like for example, most of the probes or the scanning activities that the automatic scanners are doing. So, how it works? We are receiving a stream of HTTP requests. So, differently from other, like for example, different from a network intrusion detection system, we are seeing a layer up. We are at the application level, and that's why this thing is working better and could work almost only in this context. So, there are parameters that we can extract, information that we can generalize for each request, like for example, the received and sent bytes. which kind of response code the web server gave us, the duration of the communication. And as I said before, this technique is not really smart. So the detection rate is low, but it's low enough for what we have to do. So here the request comes, we go through this classification. If we accept it, then we will pass it to the real anomaly detection engine for the training. Otherwise, garbage. What we are going to analyze in the real detection engine, because as I told you before, in the cleaning phase, we are just popping out numbers like bytes and writes, receive, send, and so on. Okay, this is a common HTTP query. It's a GET from the content management system post-nuke, so it's quite famous. So here there is a parameter called the name. This guy wants to see the news, and he wants to see the article, and he wants to see the article number 25. So as you can see, we can divide, we can classify the parameters based on their type. Here we have something that is a number, and it will always be a number. And here we have something text-based. So we have already said that the content analysis is the one that is providing you the best result, because you can make good assumption on what you should find here and what you should find here and what instead you are finding if it's an attack, for example. So if we are observing the seed parameter and then we know that it's only a number, it must be only number there. And, there is some text popping out. What could be? Could be a SQL injection or a cross-site scripting or whatever it is. I don't care. But for sure it's not a number anymore. This is an attack. So this is like the basic idea of the approach. Okay. So we have this detection engine that has like 3 subsections. One is the one that has to recognize and learn which are the numerical parameters that we have. Well, everybody knows that, for example, we have DBMS table entries commonly. Like, I want to see article 25, so the web server will process the request, the DBMS will send it back the row number 25 with its content. So, for example, for this one, we are using just a type checker. Once we learn that it's a number, we just check that it will be always a number. Then we have the second type, the short text. What we call short text is something like there is a fixed length or almost fixed, like less than 15 characters, and with almost fixed content, like func equal delete or add or view. These are commonly fields that you find inside the web application to list user, to delete user, or to do whatever, to log in or so on. And then we have, and for these we use a grammar checker. Later we will see what we mean. For the last type, that is everything remaining, we call it raw data, can be emails or binary.